These slides are going to talk you through Chapter 7. If you've never worked with classes before, they're going to take the time to kind of discuss the topics in a little bit more detail that you might need. And so these are the sections that we are going to cover. And so starting right off with Section 1, a class in C++ is considered an abstract data type. And that means that you, the programmer, are creating the data type. It's not a primitive data type. So your primitives are like your ints, doubles, characters, etc. And so you are declaring your own data type. And so you're going to specify the values that can be stored and the operations that can be done. And so those values are your instance fields and the operations are your methods. Because the user when the user uses an abstract data type, the ADT, the user doesn't need to know the details behind the scenes. And this is called information hiding, or you could think of it as what they call black box programming. Abstraction allows a programmer to design solutions to several different problems and to use data items without worrying about how the data items are implemented. It's like using the square root button on your calculator. You don't care how it works behind the scenes, you just want to know that it works. And so the square root button works and you're happy. Another example is the power function. You don't need to know how it works, you just know that it works. Abstraction is the idea that you capture the general characteristics of something without the details. So for example, an abstract triangle is a three-sided polygon. A specific triangle will be scalene, isosceles, or equilateral. A data type defines the kind of values that can be stored in and the operations that can be performed on it. So when we give a data type of integer, we know that it can only be an integer, and we won't have any decimal portions on that. And there's certain operations that can only be done with integers, such as modulus. When it's a double, we know that we're going to have decimal portions to it, and that we can perform any operations except modulus, for example. You guys have been doing procedural programming so far, where you've just been declaring little mini methods and using them within main. That's what they call a procedural programming language. That uses variables to store data. It focuses on the programming process. The data and the functions are separate. Object-oriented programming encapsulates both the data and the functions into one single object. So the object is the entity that combines both the data and the functions. The attributes, or what we call the member field variables, or what you will often be called as instance fields, are the data items for that object, and then the functions are the actions. So you want to think of the attributes as the defining characteristics. Like in our circle example, the radius was a defining characteristics, and then the member functions are those actions. Data hiding is the idea that you restrict access to all the members of the data, which is why they are private. And then encapsulation is the idea that you're bundling together the data and the procedures into a single entity. This is an example of a square. A square is defined as having a single side, that is its only attribute. The functions are setSide and getSide. So this is a kind of like a UML diagram that we did for a class diagram, because it has the name, but it's just not inside the rectangle, like we put our name up here inside a rectangle. And you have your instance fields, and then you have your functions. Notice you have a getter and a setter. Those are pretty typical. For every instance field, you will often have a getter or a setter. Why would you want to hide the data? And that's for protection. It provides a layer for people to accidentally, for them to not accidentally change your data or corrupt your data. And it's also on a need-to-know basis. Okay, a programmer can use the data via the method provided as long as the member functions work and return the correct information. You don't need to worry about the details. So, classes. A class is a programmer-defined data type. You are going to be the one that's going to define it. Okay? This is a format of a class. You have a reserved word class, you have the class name, and you have everything inside these two curly braces are what defines the class, and notice that there is the semicolon at the end of the class. Access specifiers can be public or private. Public ones, that means that you can access the functions outside of the class. That's how you call them from the driver. Private can be only accessed within the class. So private variables are used within the class. When you guys are working like with the radius in the circle, we use the radius inside the class, but we didn't call the radius directly from outside the class. We used the getRadius method from outside the class. This example is a square, and so notice we have the private data here, and that's just the side, and then we have our public getters and setters. So when you guys design your class and your class diagram, you're going to want to set up your instance fields, which will be private, and then your methods, which will be public. Now, oftentimes, you're going to have more methods than just your getter and your setter. This is just a very simple beginning class. Access specifiers can be listed in any order, and actually oftentimes you'll see out in industry that this section, the private section with the instance fields, is often placed below the public methods, and usually that's done because once you've set up those instance fields, they take up screen space at the top of your screen. They call that screen real estate, and so they want to move it to the bottom of the screen, and so the real estate is often off the screen, so you don't have to worry about it. You know what the variables are and what you want to work with. Access specifiers can appear multiple times in the class. It does not specify the default is private. So they're saying that if you don't tell it, the access specifiers will be private. When you create an object in the driver, like we did with the circle class, you're going to use the name of your class just like it was a primitive data type, even though it's not. It's what we call an abstract data type. So you use the name of the class, and then you have your names of your instance, not your instance fields, but the names of your objects. Okay? So here, if a square is created, it's going to use a default constructor, and then you could set the side, and then you could use that. Notice the dot operator. In order to use those methods, you use the dot operator, and then we output the value of that by using the getter method. So this is showing a setter method and a getter method. These lines of code would have to be put inside of a main in order to execute. Accessors are your getters. Mutators, setters, or setter functions modify a member variable. So you'll hear this terminology, getters and setters. So an accessor is a getter, a mutator is a setter. When you go to define your own member functions, they are part of the class definition. They're within the class. They're within those curly braces. You can place an entire function inside the class declaration, or you can just place the prototype. Right now, you guys are going to be defining it or using the entire function inside the classes. So a member function defined inside the class is called an inline function. And so when you do a getter method and you hit just return the side length, that's an inline function. A little bit later, we're going to learn about how to separate what's called the implementation from the definition. Also, just mention here, only short functions should be inline functions. You should, if you have a function that's more than one line, you probably should not create it as inline. Again, this is your square example, and they're showing that you have two inline functions. When you define member functions after the class definition, this is actually going to get into the second part of defining classes that we do. You're not going to worry about this to begin with. Later on in the week we will. But this is what's called a scope resolution operator. And so you use that to identify what method goes with which class. So when you use the scope resolution operator, what you're saying is this method is within the scope of this class. And so square : get side is telling us that get side belongs to the square. Conventions. Conventions are things that are typically done out in industry and that you should follow. Member variables are private. Accessor and mutator methods are public. You use get in the name of an accessor function and set in the name of a mutator functions. Also, if you calculate values to be returned in accessor functions when possible to minimize the potential for stale data. And we talked about that in the video for the circle class, and that we only defined one instance field, which was radius, and we did the calculations for the area outside of that so we would prevent stale data. Just like here, when you're creating a square, we don't want to create a variable for the area of the square. We don't want to create a variable for the perimeter of the square because that might have a chance of becoming stale data if I don't update it or if I forget to update it. So anytime that we're going to work with the square, if we want to find the area or find the perimeter, we would actually write a new method for that rather than use an instance field. When you use a regular function, it is called the control passes to the function. And when that happens, the compiler stores the return address of the call and allocates memory for that. The code for an inline function is copied into the program in place of the function call. And it makes a larger executable program, but there's less calling while the program is running. And so it could be possibly a faster execution time. So just be aware of that. Okay, I'm going to stop this video at this point. We will pick up with section 7.6 in the next video, and that's going to be creating and writing constructors, etc.